So if we look at this one, here you have a parabolic function, which is not given in a standard form. And then if you are given a hyperbolic function, it's not in a standard form, you are supposed to know how to take this and then make it to look like this, which is going to be in a standard form. Sometimes they don't even ask this how. They say determine the equations of the vertical and the horizontal asymptote. So how do we do that? We need to make sure which we are going to write the numerator such that it looks exactly like the denominator. So that's our first part. So we're going to say on number one, we have f of x, which is going to be given as x plus 2. I'm going to do this on purpose, plus 2. That's where I start. I need to have plus 2 on the denominator. I mean, on the denominator, I have plus 2. So even on the numerator, I need to have x plus 2. So I have x plus 2. Now, x plus 2 and x plus 2, you'll see they will do something to each other. But remember, here's what you have. You have minus 3 again. Now, you need a value that you can add or subtract so that you can get minus 3. What is the value that you can add or subtract so that you can get minus 5? Oh, it's minus 5. So the value that we're subtracting here, we're going to say minus 5. Okay? If we say 2 minus 5, it gives us what? Minus 3. What have we done, Tim? We wrote minus 3 in another way such that we have x plus 2. Does it make sense? And then from here onwards, I will say, but now this person goes with this one. These two, they can go together. So I'm going to split this thing and write it this way. It's x plus 2 all over x plus 2 minus 5 all over x plus 2. And then you can see x plus 2 and x plus 2, they can divide each other out. Okay? You are left with 1 minus 5 all over x plus 2. Yeah, usually it's 2 marks for something like this, x plus 2. So they'll give you 1 mark for splitting this thing, basically. That's the goal here. And then here's the other one that they like, sheet. This one is a little bit tricky because they would say something like this. They will say you have, let's take something like this. They will say you have 3 minus x all over x minus 1. Let's look at this one. This one is tricky. Because look at this one. If you look at the x of the numerator, it's negative. Okay? Look at the x of the denominator, it's positive. No? So they are not alike. So what did I do on the first one? On this one, what did I do? I said I'm going to write this thing as x plus 2 first. Okay? Now I need to use exactly the same principle here. I'm going to write this thing. I was supposed to say I need to have x minus 1. I can't have x minus 1. Even if I wanted to, I can't. Because you will always have this one which is negative. But this one here is what? It's positive. So what does the learner do if they're given something like this then? Here, Matebul, you are not going to have x, minus 1, but you are going to have minus x plus 1. They need to change, like, again, here you have x is positive, and then you have minus 1. So for you to make them to be alike, this is what you need to do. You are going to change this thing here. And then you are going to say, I'm going to first have minus x, instead of writing minus 1, because there's already minus x, I'm going to write plus 1. And then now I need a value that I can add or subtract so that I can get 3. What is the value that I can add or subtract so that I can get 3 here? What is the value that I can add or subtract so that I can get 3? Plus 2, okay? All over, look at this. It's going to say I have x minus 1. Yeah? Now remember what we do. We take this part on its own again. And then we're also going to take this part on its own. And then after that, you're going to have minus x plus 1 all over x minus 1 plus 2 all over x minus 1. Now, these two are not the same. Can you see that again? Now, in Python, we're busy with that, man. I'm teaching them which, if two things are not the same, we can make them to be the same. How to make them to be the same? We factorize with a negative. So if we factorize with a negative here, it means if I do this, look at this. If I put a negative outside, when you put a negative outside, whatever is positive becomes what? Negative. So it means with this here, you are going to have a plus. Whatever is positive is going to become what? Negative. Now you have x minus 1, x minus 1. X minus 1, x minus 1 is going to give us minus 1 plus 2 all over x minus 1. Then, once you are given something like this, there's nothing special here. You can determine the vertical and the horizontal asymptote. For this one, what is going to be the vertical and the horizontal asymptote? What is going to be the vertical and the horizontal asymptote? Here. What do you think? So we have x is going to be equal to -2 again. And then our y is going to be what to be 1. Still doesn't matter. So you can put this thing in a standard form and put it this way. You have y, which is going to be -5 all over x plus 2 plus 1. The one is positive. This one is positive. And then the other thing that they want from us is this one. Write down the value of c if y x plus c is a line of the axis of symmetry. So how do you get the axis of symmetry? Once this thing is in a standard form, you can do something like this again. And then they want the one with a positive gradient. Yeah? So I'm going to have y, which is going to be equaling to x plus 2 plus 1, which is going to be equaling to x plus 3. Therefore, what is going to be our c? Our c is going to be equal to what? To 3.